For hundreds of millions of years, the universe was wrapped in darkness deeper than anything we can imagine today. Picture a cosmos infinitely vast, yet silent and empty, without stars, planets, or any hint of the familiar night sky we see above us now. In this ancient time, there was no fire to warm the void, no source of light to pierce the endless black. But this was not a darkness of despair. Instead, it was the calm before the first great act, a hush before the awe-inspiring drama of cosmic creation was set to unfold. In this primordial era, the universe had already experienced its birth in the event we call the Big Bang, a singular explosion of everything we know, from matter to energy, to the very fabric of space and time itself. For the first few 100,000 years, the universe was a seething, opaque soup, a plasma so dense and hot that atoms could not even form. Light itself was constantly scattered by free electrons unable to travel any great distance. But slowly, as the universe expanded and cooled, something extraordinary happened. At around 380,000 years after the Big Bang, electrons and protons combined to form neutral atoms, primarily hydrogen and a bit of helium, an epoch known as recombination. For the first time, space became transparent. Light, the cosmic afterglow we see today as the cosmic microwave background, was free to travel. Yet with this newfound clarity came an unexpected emptiness. There was nothing to shine but that relic glow, quickly stretched and redshifted into invisibility by the relentless expansion of space. This was the start of the so-called cosmic dark ages. It was an era of silence, of waiting. Across the vast expanse, the primordial gas was almost perfectly smooth, only the faintest ripples, tiny variations in density left over from the earliest moments, disturbed the calm. These ripples would be crucial. Under their gentle influence, gravity began its slow and patient work. Over millions of years, these slightly denser patches of hydrogen and helium drew in their surroundings, growing denser still, coalescing into invisible islands in the infinite sea. The universe was setting the stage for something spectacular. For ages, this was a universe of potential, not realization. The invisible hand of gravity shaped the cosmos in silence, gathering the raw material for an impending transformation. In these dark eons, there were no colors, no patterns, just the cold, unyielding night and the gentle gravitational gathering of gas. But as each cloud grew, as each concentrated region of gas became thicker and thicker in its heart, the stage was nearing set. The darkness was waiting to be broken, not by an external hand, but by the brilliance soon to be born from within. Eventually, within these densest knots of pristine gas, conditions crossed a crucial threshold. Under the immense pressures and temperatures found at the heart of each growing cloud, atoms of hydrogen were forced ever closer together. When they hit the tipping point, nuclear fusion, a process that powers every star, ignited for the first time. From utter blackness, points of light burst forth. Their radiance blazed with a power beyond anything later generations of stars would ever achieve. For these were the universe's originals, the first stars, heralds of creation, gateways from darkness into fire. They are known as the population 3 stars, and in this cosmic dawn, the universe changed forever. What made these first stars so extraordinary? Unlike the stars that fill the night sky today, these giants were forged from a universe still pure, composed only of hydrogen and helium, untouched by heavier elements. This untainted simplicity had profound consequences for how these stars formed and lived. In the modern cosmos, heavier elements, even in trace amounts, help to cool interstellar gas. They allow clouds to shed heat more effectively, fragment into smaller clumps, and create a variety of stellar masses, from titanic giants to modest red dwarfs. But the early universe lacked all these metals, carbon, oxygen, nitrogen, that aid cooling. As a result, the gas clouds of ancient times grew much larger before collapsing. The first stars, born from this primeval matter, were titans. Estimates suggest they could be 100, 200, or even 300 times the mass of our own sun. Imagine, for a moment, the explosions of brilliance that must have marked the birth of these behemoths. For the first time, the cold universe was lit not just by the pale echo of the Big Bang, but by the shattering brilliance of starlight. These stars burned with blue-white intensity, their surface temperatures soaring tens of thousands of degrees higher than our sun. Their cores were cauldrons of energy, fusing hydrogen into helium through sheer weight and force. Yet for all their might, these stars were fleeting. Their enormous mass was both a blessing and a curse. Fusion in their cores proceeded at a breakneck pace, consuming their fuel hundreds of times faster than smaller stars today. While our sun expects to live 10 billion years, a first-generation star might last only a few million. A cosmic firework, brilliant and brief. During these short but spectacular lives, these stars transformed the universe in ways that would echo for eternity. One of their greatest gifts lay not in how they shined, but in how they ended. Their deaths would be cataclysmic, explosive events that shaped the very chemistry of the cosmos. As these colossal stars exhausted their core hydrogen, fusion continued relentlessly, building ever heavier elements, helium to carbon, carbon to oxygen, oxygen to magnesium, and so forth. But when the star at last forged iron in its heart, the energy balance tipped fatally. Iron could not yield more energy by fusion, and the core collapsed in a heartbeat. For many of these titans, the finale was not merely a supernova as we know them now, but a hypernova, a far more explosive, energetic catastrophe. In these moments, the star was torn limb from limb, and the nuclear inferno unleashed scattered the heavy elements forged in its belly across vast interstellar distances. Elements like carbon and oxygen, building blocks for all life, were flung out to seed the next generation of stars and planets. Even iron, the atom at the center of every red blood cell on Earth, made its first leap into the universe from such stellar deaths. These brief, intense supernovae and hypernovae were the first cosmic alchemists. The population 3 stars were, in every sense, the original creators of everything that would come after: planets, oceans, and living beings. The universe's earliest chemistry experiments happened in these infernos, and the products were the materials from which we, much later, would arise. But their legacy was not finished at the moment of their death. The energy and radiation they unleashed did not simply light up their local neighborhoods. They changed the very character of space. When the first stars ignited, the light they emitted was not just visible brilliance. Their intense ultraviolet radiation, far more energetic than sunlight, wreaked fundamental changes on the surrounding interstellar medium. Before these stars, the hydrogen gas that filled the cosmos existed as neutral atoms, content and dark. But the flood of photons from these primordial suns began knocking electrons off hydrogen atoms, ionizing them once again and transforming the gas into a glowing, transparent plasma. This epoch is known as the Age of Reionization. It was a period of transition, when the universe, warmed by the brilliance of these early stars, changed from opaque and cold to a place where light could travel freely once more. At the beginning of the reionization era, only scattered bubbles of ionized gas surrounded the newborn stars. But as more and more stars formed, and later as galaxies and black holes ignited, these bubbles merged and grew until the darkness of the cosmic dark ages was banished forever. By the end of reionization, a few 100 million years after the first stars blinked awake, the entire universe had become transparent and luminous. Structures large and small began to assemble. Galaxies, clusters, and superclusters, built from the ashes of those earliest beacons. With the passage of billions of years, those first stars are now long dead. Their short lives, so brilliant, left behind no direct traces that we can see with our naked eyes. Indeed, not a single population 3 star has ever been observed directly by astronomers. The reasons are simple and inescapable. Their very nature made them ephemeral, doomed to live and die in the universe's earliest days. The few that might have lingered would long ago have faded to darkness or collapsed into black holes. Yet, we are not entirely ignorant of their existence. Indirectly, their fingerprints linger in the light we capture from the most distant, most ancient objects in the sky. When astronomers peer deep into the cosmos, even with the most powerful telescopes, they see the afterglow of early galaxies, collections of stars and gas whose properties hint at the chemical legacy of the population 3 giants that came before. The cutting edge of this search is now sharper than ever. With the launch of the James Webb Space Telescope, humanity possesses an eye capable of looking back further across time and space than ever before. In the long infrared and faintest radio, JWST can tease out images of infant galaxies, mere hundreds of millions of years after the Big Bang. Within some of these distant smudges of light, astronomers seek evidence for the second-generation stars, those enriched by the metals produced and scattered by the very first behemoths. By measuring the chemical composition of these early galaxies, by deciphering the faint glow of their oldest stars, scientists are reconstructing the ancient past. Every trace of carbon, oxygen, or heavier elements is a breadcrumb, leading us to the moment when the first cosmic forges burned. While the first stars themselves are gone, Their ashes echo through time, their handiwork written into every atom of heavier matter in the universe. The impact of these first stars cannot be overstated. They ended the universal darkness, breaking the eternal night, creating the very conditions under which the cosmos we know could take shape. Without their brilliance, without their explosive demise, the universe would have remained unstructured, a simple mixture of hydrogen and helium, featureless and inert. There would have been no planets, no rocks, no water, no life. The evolution of galaxies, the formation of solar systems, the emergence of living beings, all are consequences, ultimately, of those first fiery hearts. Some of the most profound mysteries remain. We believe that the remnants of these earliest stars may still haunt the universe, lurking as massive black holes. Over cosmic time, these could have acted as seeds, drawing gas, dust, and stars to them, anchoring the formation of the first galaxies. The monstrous black holes inhabiting the centers of galaxies today may well be the ghostly children of those vanished titans. In each of us, the story of the first stars resonates deeply. The oxygen in your breath, the calcium in your bones, the iron circulating in your blood, all were made possible by stars who lived and died billions of years before our sun was born. We are, quite simply, the living memory of the first star's brief brilliance. The narrative of cosmic history would be incomplete without this opening act. The transformation of utter darkness into a universe rich with diversity, structure, and meaning. The population 3 stars wrote the chemical prologue, forging the alphabet of atoms that, much, much later, would spell out planets, oceans, and even consciousness. And their story is not finished yet. With every new telescope, with every deeper look into the farthest reaches of space, humanity edges closer to witnessing the full beauty of this transformation. We seek the moment when creation's curtain was raised, and the first stars sang out into the emptiness. For now, their tale is a mixture of theory and tantalizing hint, a grand cosmic myth built on the foundations of physics and the sparse but precious clues the universe reveals. But what remains certain is this. From a wasteland of darkness, the first stars gave us fire. Fire that has never since gone out. Born in darkness, they blazed and transformed the cosmos. The first stars were not just fire. They were the genesis of meaning, the wellspring from which everything else has flowed. They set in motion a chain of events that led, eventually, to you, listening, thinking, and wondering about your place in this ancient story. As we reflect on that luminous dawn, consider for a moment the tapestry of time, billions of years ago, before planets, before any definition of life, before even the familiar spiral arms of galaxies swirled through space. There were only these first stars, machines of cosmic alchemy, dashing themselves against the night to forge the foundation of everything. Their brilliance has not faded, for in their ashes, the universe became all it is today. Tomorrow we journey further. We will explore how the deaths of these earliest stars, these cosmic architects, gave rise not only to the chemical riches of the universe, but to the potential for planets, oceans, and perhaps even life itself. We will trace the transformation from elemental hydrogen to the dazzling diversity of stardust, and ultimately, to beings who can look back and strive to understand it all. Born in the depths of darkness, the first stars lit the path for all who would follow.